Hello students, welcome to Microwave Engineering Laboratory, and today's experiment is VSWR measurement of matched load or unknown load. Both you can call VSWR measurement of matched load or unknown load. The aim of the experiment is to determine the VSWR of an unknown load. You can take matched load or mobile short. So here VSWR means voltage standing wave ratio. Let's coming to the operators. The required operators is first one, microwave source, klystron or gun diode, isolator, frequency meter, VSWR meter, variable attenuator, slotted line, tunable probe, waveguide strands, movable short or matched termination. You can consider both, and SS tuner. So these are the required things to do the experiment. Next, coming to the block diagram. So this is what the experimental setup which we are using in the laboratory to do the experiment. The first one, microwave source. Source is connected to the isolator, isolator to the variable attenuator to frequency meter to slotted section. Slotted section is connected to the SS tuner to matched load. Other side, slotted section to the tunable probe is connected to the VSWR meter or CRO. You can use both also. So initially here, microwave source means klystron power supply. So when you switch on the power supply, which is connected to a klystron mount, when you energize klystron mount by applying the voltage using the klystron power supply, so microwaves generated, whatever the waves are generated, which is passing through the isolator. Here isolator is working like a uniline, so it directs the total energy to a particular direction. Okay, only one direction, and that too towards to the attenuator and frequency meter. And variable attenuator, so it stops the some energy, means attenuates the microwave energy. Okay, then next, frequency meter. By rotating the frequency meter, we can allow the, or we can set a particular frequency to a microwave energy generated by the source. Here we are using the band X band. The values start at 8.2 to 12.4. So this is what the exact band in between. So you have to set a particular frequency or exact frequency to the energy. Then frequency meter to the slotted section. Slotted section has a scale. By moving the scale, so you can calculate the minimum distance on that particular scale. And it is connected to a tunable probe. You can tune the frequency of the signal, I mean powers of the signals. Then it connected to a CRO, or you can use the power meters also. Other side, there is a SS tuner, side screw tuner, and that is connected to a matched load. The final is the matched load. So now you have to calculate the VSWR after connecting the matched loads. Next, practical observations. Whatever the things you have to calculate in the laboratory. First, you have to write down the input voltage, then beam voltage. Remember, beam voltage is always in between 230 to 240 volts. Then rippler voltage, by rotating the rippler knob in anti-clockwise direction, you have to fix the maximum signal power, maximum signal strength, or maximum power on CRO screen. Okay, so by maximum values, then you have to calculate that particular voltage as a rippler voltage. Example 201, 203. So while you're rotating the knob, you see the signal strength increasing and decreasing. You have to fix the increased or maximum signal strength. Then beam current. Okay, beam current is always below 18 milliamps. It should not exceed the 18 milliamps. If it is exceed, there is a chance to burst out. So mount operates at high powers, right? High voltages, right? So be aware, you have to fix the beam current below 18 milliamps. Next, let's see the tabular forms. So here you have to do the experimental 3 steps. The first one, when you connect the matched termination, okay, matched termination. So what is the power and what is the VSWR? Both we can find by using the power meter straight away. Okay, you need not to do anything. So just connect the tunable probe to the VSWR meter, I mean power meter. Then there is a 2 knobs. If you click the power knob, it shows the power value. If you click the, if you press the VSWR knob, it shows the voltage standing wave ratio directly. Then detach the matched termination from the setup and connect the movable short. For a movable short, what are the values? Power values and voltage standing wave ratio values. As well as connect the horn antenna. Try to find out the power values and voltage standing wave ratio. See, here I am giving some observations, so which you have to find out in the laboratory. So beam voltage, I told you now, so it should not exceed more values. So here I have taken the 242 volts, beam current 17 milliamps, rippler voltage minus 138 volts. Here minus sign representing the reverse direction, and the maximum voltage is 14 millivolts. See, case 1. So initially connect the detector mount and try to find out the power. Okay. Then after find out the maximum power by using the detector mount, go to the matched load. So using a matched termination, okay, matched termination or matched load. After connecting the matched load, try to find out the power values and standing wave ratio. Here the power is minus 146 dB and standing wave ratio is 2. When you connect the horn antenna, the power is minus 46.4 dB and the power is, voltage standing wave ratio is 1.93. Okay, then if you go for the mobile short also, it gives a different values. So here I have tried 2 things only, matched load and horn antenna. So just to compare it, it is a matched load means it completely blocks the energy, right? Obviously, when it blocks the energy, there will be a high standing waves. So standing wave ratio is high. When you connect the horn antenna, we know the principle of antenna. So when the impedance values are matching, line impedance and impedance value of the antenna, characteristic impedance which is equal to the antenna impedance, then only it is acting like a antenna or a transporting device. So to satisfy that condition, always remember voltage standing wave ratio is less than or equal to 2. Here the standing wave ratio is 1.93. So condition is satisfied. Let's coming to the Viva questions. I have raised some questions here. The first question is, does voltage standing wave ratio vary with line length? That is a question number 1. Question number 2, can the magnitude of the reflection coefficient rho be greater than 1? And question number 3, can voltage standing wave ratio be negative? If so, why? Then question number 4, is there a minimum length of the transmission line, required on either side of the VSWR meter for valid readings. Question number 5, is the characteristic impedance of the sampler line section important? Question number 6, what is an acceptable voltage standing wave ratio? And question number 7, define voltage standing wave ratio. And question number 8, define reflection coefficient. And question number 9, what is a standing wave? Question number 10, what is the reflection coefficient? Next question, 11th one, when do standing waves form? Question number 12, how they are useful in the microwave engineering? Question number 13, what is minimum value of voltage standing wave ratio? Question number 14, what is the range of the reflection coefficient? So these are the questions I have raised here. So kindly answer to these questions and try to learn the concepts. Thank you. Thank you so much. Let's move to the laboratory, do the experiment and take the observations. Okay. Then after taking the observations, again, I'll explain on board. Yeah, let's move.
Hello students, welcome to Microwave Engineering Laboratory, and today's experiment is VSWR measurement of a matched load, and this is what the microwave test bench. Initially you have to switch on the cooling fan and make sure the air should flow towards to the klystron mount. It is a high power generator. Switch on the power supply. And klystron power supply incorporates different knobs. Select the modulation knob to AM mode and rotate the beam voltage knob and fix the voltage in between 230 to 240. And see the current, and beam current should not exceed 18 milliamps. Then select the rippler. By rotating the rippler knob in anti-clockwise direction, fix the maximum signal strength on CRO screen. See here. So you have to fix the maximum signal strength appears on CRO screen. And klystron power supply is connected to the klystron mount, and mount generates the high powers, microwave energy, which is passes towards to the isolator to variable attenuator to frequency meter to slotted section, and slotted section to detector mount. And this is what the outputs are. By rotating the frequency meter, see, this is what the frequency meter. By rotating the frequency meter, you have to fix the particular frequency to the microwave energy generated by klystron mount. So when you are rotating, you will found a dip. So this is what the required frequency within the band value of 8.2 to 12.4. Now calculate the remove the knob, connect it to the VSWR. So it is a SWR meter. You can calculate the power straight away. You change the mode, select knob. See here, you can calculate the power straight away. This is what the setup number 1. In case 2, remove the detector mount from the test bench, connect the match determination, match determination, and second step, connect the movable short, okay, and third, antenna, horn antenna. So when you connect the match determination, so whatever the energy, take the tunable probe and connect it here. Tunable probe. So this is what the tunable probe. You have to connect the tunable probe on a slotted line. Remove the probe. Connect the probe to slotted section. There. Remove the detector now. See, in case 2, connect the match determination and fix the maximum signal on CRO screen. The same way, connect the probe to SWR meter and take the power and standing wave ratio. So here the power is 9 dB. Okay. So select the SWR knob and you will see the standing wave ratio in normal mode. Okay. And next case, check out the match determination and connect the movable short and repeat the experiment. So calculate the power as well as the standing wave ratio. Next, connect the horn antenna. So previously we blocked the energy and we check the SWR and power values, but now connect the horn antenna. When you connect the antenna to a transmission line, now it is acting like a transporting device. Okay, so standing waves should be less. See, voltage standing wave ratio, it shows here 1. See, standing wave ratio should be less than or equal to 2 when you connect the antenna to a transmission line, because it is acting like a transporting device. It is not like a storage element. So calculate the power as well as the standing wave ratio. So this is how you have to do the experiment in laboratory. So you have to perform 3 cases. First one, connect the detector mount and take the power and standing wave ratio. The next, remove the detector mount and connect the match determination. And repeat the experiment same way. Next, connect the movable short. Remove the match determination, connect the movable short and check the power values and SWR reading. And finally, connect the horn antenna. Okay, check the standing wave ratio and power values. Okay, thank you so much. Hello students, after performing the voltage standing wave ratio measurement of matched load practically in laboratory, the observations are The beam voltage, what we see, 242 volts. Then beam current, 17 milliamps. Rippler voltage, 138 volts. And maximum voltage, 14 millivolts. See case 1, when you connect the detector mount to a test bench, I have to take the power. The power is 46.10 dB. Let's come to the case number 2. Remove the detector mount from the test bench and connect the matched termination to a slotted section. Apply a load, and for that load, power is 46 dB and standing wave ratio here value 2.6. Value is 2.6. And case 3, instead of matched termination, when you connect the movable short to a test bench, and here the power 42 dB and standing wave ratio is in 4. Okay, reflection coefficient is 4. And finally, when you connect the horn antenna to a test bench, we know the concept. When you apply a load to a test bench, matched determination and movable short, when you block the energy, whatever the energy generated by source which is traveling towards to the load side, when you completely block it, and entire energy take the diversion and travel towards to the source side. Simply it is acting like a standing line. In that case, the total setup acting like a storage element. Transmission line acting like a storage element. But when you connect the horn antenna to the test bench, so when antenna means the characteristic impedance of the transmission line, which is equal to the impedance of the load, antenna, simply it is acting like a transporting device instead of storage element. And to satisfy that one, always remember standing wave ratio should be less than 2 or less than or equal to 2. So for that, when you connect the horn antenna here, we see power value 46.4 and standing wave ratio is 1.93, which is less than 2 only. So remember, this condition should be satisfied. Okay, and this is how you need to do the calculation part. Thank you so much.